introduction to the multiplication laws of exponents, and we're going to be using PEMDAS. So take a moment to write this down. We're not going to be going over all these concepts today. We're going to be in the M section, but I just want you to fill this out so that way you are familiar with it when we go over the other laws of exponents. The first thing I'm going to do is put a placeholder with everything. If you don't see an exponent on your terms or on your variables, you need to put a placeholder one there. Then, if we have a set of parentheses, we're going to see if we can clean up anything on the inside. We're going to move on to E. If you see an exponent touching the outside of your parentheses, you're actually going to multiply it inside. We're not going to be talking about this law today. Today, we're going to be talking about the M, the multiplication laws. And for those laws, you're going to smush or combine your variables. One of the last ones we're going to be discussing is division, where you're going to cancel by using two questions. How many are left and where are they left? And then also in between, I'm squeezing in something else that's new. So placeholders is new in the PEMDAS line. But also we're going to be talking about negative exponents and zero exponents towards the end of our exponent concept. We are not going to be adding or subtracting in terms of PEMDAS. We're going to be doing some other things. So the first law I'm going to be talking about is called your multiplication law or your product law. It says when you have two terms with the same base, all you need to do is add your exponents. For instance, if I had x to the third times x to the fifth. Now, if I had all the time in the world, I'd be able to write this out in expanded or standard form. Okay, this is in exponential form so far. And that would mean that I have 3 x's here, x times x times x, and that I have 5 x's here. 1, 2, 3, 4, 5. And what would be in between them all is a time symbol, which basically means in standard form, I have 1, 2, 3, 4, 5, 6, 7, 8 x's in a row. If I write it in exponential form, it would be x to the 8th. So you're saying I have 3 x's and 5 x's. I have 8 x's altogether. Now this goes for any type of variable. So if I have m to the 5th, n to the 3rd, m to the 6th, let me see if I can squeeze it in, there we go, and n to the 2nd. Well, let's see, do I have any other m's I could put together? Yeah, let's smush these together. I have 5 m's and 6 more m's. How many do I have altogether? I have 11 m's together. Now let's take a look at our n's. The n's cannot be with the m's. I have 3 n's here and 2 n's here. How many do I have all together? I have 3 and 2, which is 5 n's. Sorry, that's really hard to read. 5 n's all together. Don't put them together. The m's and the n's are not buddies. You can't put them together and write mn16. That is not allowed. Let's try another one. I have 2, x to the 3rd, x to the 6th, and x to the 7th. Well, the 2, there are no other numbers like it, so I'm just going to drop down that 2. But here I have 3 x's, 6 more x's, 7 more x's, so let's do them together. 3 plus 6 is 9 x's so far. 9 and then 7 are 16 x's. This 2 did not change because it didn't have anything that was similar to it, no like terms in order for it to be combined. Now, if you're wondering, well, what happens if the 2 does have some other stuff going on here? Let's check this out. If I have x to the 3rd and then I have a 4x to the 5th, well, let's do the x's. The x's are easy. I have 3 x's and 5 x's. That's 8 x's altogether. You can even, check this out. You guys know this property here where you can move things so that they're next to their buddies? Yeah, you can do that. If that makes your life easier, go ahead so you understand where the x to the 8 comes from. It also helps you understand where this is coming from. So ask yourself, what is 2 times 4? Remember, these are all multiplication. 2 times 4. 2 times 4 is 8. I know that some of you guys are thinking 6. And remember, this law is only for exponents. Nobody said to add your big numbers. I'm saying add your exponents. Well, these are not exponents, so you can't add them. 2 times 4 has always been 8 and will always be 8. So do not add them. All right, let's do another one like that. I have 6. Let's change it up. A to the 3rd. B, ooh, let me do that because I haven't talked about that yet. C, and then I'm going to say 4A, B to the 7. All right, so the first thing I'm going to notice is that some of my variables don't have exponents. I'm going to put placeholders, and my placeholders are always 1. So if you have a letter, and I even like to do my numbers, if I have anything that doesn't have an exponent, put a little 1 there. And the numbers are not going to be important with the exponent 1 until later on, so don't really worry about that. So let's see what we can do. I'm going to do the A's. I have 3 A's here, and I got 1 more here. That's why it's helpful to put the 1 there, so you don't think that 3 and none. This isn't none, this is 1. 3 and 1 is 4. Make sure that's a 4, not a 3. Let's check out our B's. I have 1 B and 7 B's. 1 B and 7 B's gives you 8 B's. Let's check out our C's. Well, I only have this set of 2 here. I don't have any C's over here. I still have 2. I have 2 C's. And let's check out our big numbers. If you need to pull them out on the side, I like doing a little recall box. This is a 6 times a 4. Let's check this out. 6 times 4 is not 10. 6 times 4 was 24, and guess what? It still is, because this law is not for big numbers, it's for exponents. So let's move on to our next law. It's called power of a power, and you're not going to be tested on the names, but I like to be a little formal sometimes. So I'm going to give you the formal name just so that you know what I'm talking about. Map it up. Power of a power. So what this means is I'm going to have an item inside my parentheses and something else to the outside. This is very similar to the distributive property. It's not called distributive property though. Do you see how this letter or this exponent is touching the outside of the parentheses? I'm going to distribute it into the parentheses, which means I'm going to multiply my exponents. If I look at my PEMDAS list, this is an E. Do you see an exponent touching the outside of your parentheses? If so, you're going to times it. That's a little times symbol there on my arrow. You're going to times it to the exponent inside the parentheses. So I'm going to give you an example, and I'm going to explain why it works. So let's say I have x to the 3rd to the 4th. What this in actuality means is that I have 4 of everything inside the parentheses. If I have time, I would be able to write it once, twice, 3 times, 4 times. And if I had time, I would apply my last rule, and I would say that I have 1, 2, 3 x's, 1, 2, 3 x's, 1, 2, 3 x's, 1, 2, 3 x's. This becomes very time consuming. Not only that, but there's a good chance I'm going to make a mistake. If I had time to add this all up and write it out, I would see that there are 12 x's. Well, let me tell you, this is another way you could do it. There's an exponent touching the outside, which means I'm actually going to do 4 times 3 to get 12 x's without having to write it out. All right, so let's try another one. Exponent, so I have x to the 5th, x to the, let's say, 6th. Well, I don't have time to write these all out, so I'm going to do exponent times exponent, 30. Imagine having to write out 30 x's and hoping that you don't accidentally make a mistake with your counting or your writing. We definitely don't have time for that. So exponent, doesn't matter what letter you use. You could use A for Alvarez. Let's say 2 to the 3rd. Bam. All you're going to do is exponent times exponent and get A to the 6th. Now let's go ahead and combine this with our previous law and do a little bit of an extension. So I'm going to say x to the 5th times x squared to the 3rd. And I want to simplify that because I cannot have more than one type of each letter. So I can't have x's here and x's there. That means that I did something incorrectly or I'm not done cleaning it. So the first thing I'm going to do is make sure everything has an exponent. So this letter has an exponent, check. This letter has an exponent. I'm going to see if I can clean anything inside my parentheses. Well, no, this is the only thing inside my parentheses. You can't do anything. Is there an exponent touching the outside of my parentheses? And there is, so I actually have to do that first. Exponent times exponent to get x to the 6th. And remember, I'm only doing one step, one line, so I'm going to drop this down. The next thing I'm going to do is see if I can smush or combine anything, basically making sure that there's only one of each type of variable. You're not having y's on top, y's here, there, everywhere. You're going to put them together. So I have these two x's, which I can put together because they're the same type of letter. I have 5 x's here, 6 x's there. That means I have 11 x's altogether. The only time you're allowed to multiply is when you have an exponent on the outside of your parentheses. As soon as your parentheses are gone, you are no longer multiplying. Let's try another one. A lot going on here. Let's go to our checklist. Does everything have an exponent? First thing I'm going to check for is, does something need a placeholder? This one's good. We're good. We're good. Well, this one doesn't have an exponent. Let's give it an exponent. All right, second thing, can you clean anything inside my parentheses? Well, there's only one thing inside my parentheses, so I cannot clean it. It's already clean. Do I have an exponent touching the outside of my parentheses? Yes, sir. Let's go ahead and make that exponent times exponent is 12. I'm going to bring everything down one step, one line, one step, one line. Oh, bring down my m to the 1. Next thing I'm going to do is, do I have anything I can combine? Yeah, look at all these m's. Let's put them together. So I have m2, m4, that gives me m6. One step, one line. I'm not trying to be fancy, making a mistake. Put them together. I have 6 and 12. That gives me a lot. That gives me 18 of these. Thing 18 and 1 gives me 19 all together. All right. Now this also works if you have multiples. So let me erase part of this. It's getting a little dirty here. Let's check this out. Let's see. I have, I'm not a fan of B's. B's look kind of like 6s to me, depending on how sloppy your handwriting is like mine. K, K5, K2, to the 3rd power. Got a lot going on there. All right, so placeholders. Does anything need an exponent? Let's check this out. No, yeah, let's put a 1 there. Oh, 1. No, we're good, we're good. All right, can I clean anything inside my parentheses? I'm gonna notice there's only one thing, so no. One thing, so no. Do I have an exponent touching the outside of my parentheses? Well, yes, we do, so let's do that. This is the only time I'm allowed to multiply is when I have an exponent touching the outside. This becomes K6. This becomes K12. Everything else, just drop it down. I got a K to the 1, a k to the 5, and a k squared. And then I'm gonna see, can I smush anything? Yeah, let's put some stuff together. We have k7, drop it down, drop it down. I'm doing one step, one line. Here I have a 12. There I have a 14. And last but not least, I'm gonna put these together. That's a lot. That's a lot of variables, k to the 26. The last rule is almost exactly like this one. In fact, the name is almost exactly the same. It's called power of a product. And again, this is very similar to the distributive property. So when I have two different variables inside, what you're going to do is, what you're gonna do is you're gonna give that to everything inside, just like we would if it was the distributive property. You're gonna multiply the outside number by every exponent on the inside. And the reason why is exactly the same as before. So example, I'm gonna say m to the 1, p to the 2. I'm not gonna be fancy. This means I have each of these 3 times. I have an m1 once, m1p squared twice, m1p squared 3 times. I can put all the m's together. I have 1, 1, and 1. That's 3 m's. I have 2, 2, and 2 p's. That gives me 6 p's. If I had all the time, I would write out the 2 p's here, 2 p's there, 2 p's there to indicate that there are 6 p's, but we don't have time for that. So let me give you an example. X squared, y to the 5th, and to the 6th. So I'm gonna see, does anything need a placeholder? No, they both have exponents. Can I put them together inside? No, x's and y's don't get put together. Don't make it xy to the 7th. That is not correct. Do I have an exponent touching the outside of your parentheses? Yes. So you're going to distribute to everything inside, and when you do, it has to be multiply only exponent times exponent. So exponent times exponent gives you a 12. Exponent times exponent gives you a 10. And check, can I put anything together? Can I smush anything together? No, they're 2 different letters, so you can't put them together. So an x to the 3rd, y. Let's put an x to the 5th on the outside with a 2 on the outside. First thing I'm going to do is check to see if there are any placeholders needed. And yes, there are. This y does not have an exponent. Give it a 1 exponent. Second thing, can you clean up inside the parentheses? Nope, these 2 cannot go together. They're not friends. Next thing, do you have an exponent touching the outside of your parentheses? Yes, so let's go ahead and multiply. This becomes x to the 6. This becomes y to the 2. This x to the 5 just drops down. Do not give it the 2 exponent because it's not inside the parentheses, just like our distributive property. Last thing I'm going to do is see, can I put anything together? Are there too many of the same type of letter? Yes, you can't have x's here and x's there. That's not allowed. You got to put them together. I have 6 x's here, 5 x's there. That gives me 11 x's and 2 y's. Do not put these together because they're not the same variable. All right, the same thing goes for these placeholders are also for numbers or coefficients, the numbers in front of our terms. First thing I'm going to do is make sure everything has an exponent. This 4 does not have an exponent. I'm going to put a 1 there. Second thing, can I put the inside of my parentheses together? No. So I'm on E, exponent. Exponent times exponent. Do not do exponent times big number. This is not a 12. It's exponent times exponent. It becomes 4 to the 3rd. Exponent times exponent. This becomes x to the 15th. Now 4 to the 3rd means I have 4 times 4 times 4, which is not 12. 4 times 4 is 16. 16 times 4 is 64. And if you're thinking, oh, I was really close, I was 12. I got 12x to the 15th. Would you rather have $12 or $64? There's the big difference. So please make sure you're doing that correctly. Now the reason why it works is I have 3 of everything on the inside. So remember, I have 4x to the 5th once, times 4x to the 5th twice, times 4x to the 5th 3 times. I have a 4 times 4 times 4. These are all timesing each other, which is where the 64 comes from. I have 5 of these, 5 of these, 5 of these, which is where the 15 comes from. So those are your exponent laws. Do not forget that there's a combination, but if you write this down on the top of your paper when you're doing your work, it will help you get the answer correct. You should not be jumping to smushing before doing your exponent. You should not forget your placeholders, because if you do, there's a good chance that you're not going to do your exponent correctly. Like a lot of people would think that this is 4x to the 15th because they would forget that placeholder there. It's very important that you do that.